Hi, this is Mr. Mitchell with a video that continues talking about phases. And there are some phase change exceptions that are kind of neat, and I need to tell them to you. One is, well, you're familiar with solids and liquids and gases, and you may have heard of plasma. It's less familiar with us, however, and you probably know it as what lightning is made of and what comes from the sun. But what does plasma have to do with the molecular movement that we studied with solids, liquids, and gases? As a reminder, solids, scientists think that they are moving. The kinetic theory says that all the solids have molecules that are vibrating. If you have more vibration and more heat, you have liquids. If you have even more movement, when you add more heat, you have gases. So plasma is actually even more movement and heat than gases. So that's where it stands amongst how much molecular movement does plasma have. And it turns out it has a lot of molecular movement. And you can see down here it says plasma molecules plasma molecule vibrations are so strong that they even force the electrons off their atoms. And the universe as a whole has more plasma than it has solids, liquids, and gases. We are fortunate here on Earth to have the stability and lack of intense heat that you do have in some places in the galaxy. So we have more solids, liquids, and gases, and the rest of the universe probably has more plasma. Here's another exception. And this one has to do with water. Water expands when frozen. Do other substances expand when frozen? No. Other substances expand when heated. You may remember the examples of roads and bridges. They purposely make grooves like this on bridges, so when the sun expands, the sun heats up and expands these roads, they have a place to go. Same thing with a thermometer. It expands whenever you give heat. The liquid in it expands. So water is kind of an exception. You may remember back in 6th grade you studied how if you have water inside a rock and it freezes, the ice is bigger than the water was and actually helps destroy some of the rock. And the reason it does this is because of its bonding. Here you can see an illustration of bonded molecules inside liquid, and here are the bonded molecules inside ice. The bonded molecules inside ice have positive and negative charges. And inside ice, the positives and negatives bond together, which leaves space in between the bonds. And that's why water expands whenever it is frozen. It's also why it is less dense. In fact, it's less dense than water. And that's why ice floats on water, because the less dense stuff floats to the top. Another exception is something called amorphous solids. Now, amorphous solids melt gradually. Is that how other things melt? Not really. Other things have a specific temperature at which is its melting point, and boiling point also, but we're talking about melting point here. Whereas you take something like glass or butter or cotton candy or sand, and they don't completely melt at that temperature. At 32 degrees Fahrenheit, all the ice is going to melt, and it'll be gone by the time you get to 33 degrees Fahrenheit. So look at this butter. In this pan, you can see you have bubbling up of boiling stuff, but all the butter's not even melted yet. If this were another substance that was not amorphous, then all of it would have generally melted at a certain temperature. Cotton candy, I'm sure if you've had cotton candy, you have seen the melted sticky stuff around the outside, but the rest of the stuff is not melted at all. So the reason why you have amorphous solids, or I guess a distinction between amorphous solids and everything else, is that most everything else has a crystal structure. A crystalline structure is in most solids. So as a result, most solids, once it hits a certain point at which this structure breaks down, it all breaks down. But amorphous solids don't have that same particular structure with every different molecule. So as a result, when there's enough heat to break down some of it, all of it won't necessarily be broken down. And a final exception is going to have to do with crystal structure in liquids. Now, I mentioned in the previous slide how most crystal structure breaks down whenever it melts. But that's not true with all melted stuff. All melted stuff forms into liquids, but some of them end up keeping their crystal structure. LCD, liquid crystal displays on screens for TVs, on screens for cell phones, are in part composed of individual crystal elements called pixels. And you can see in this diagram, we have the liquid crystal layer that happens to be in within other layers of mirror, glass, etc., that helps make up the screens of TVs and of cell phones and the like. So of our exceptions were plasma. Plasma is much faster in molecular vibration than the others. We had water is an exception because it expands when it's frozen. We had amorphous solids melt, and most things are not amorphous, but amorphous solids don't melt all at once. They melt gradually. And finally, these crystal structures, these liquids, there are some liquids that actually have a crystal structure, and one of them happens to be the liquid crystal displays that you see in your TV and phone. Hope you learned a little bit about these phase change exceptions.